confidence intervals, and now the difference between this and the last chapter. In the last chapter, we already knew somehow magically the population parameter, and we would take a sample and figure out the probability of it being above or below a certain value. Now we're going in the direction that we really want to go in, which is where we take a sample statistic to determine something about the population parameter. So when you construct a confidence interval, there's three conditions that you always have to check in your plan, and two of them you're totally familiar with already that we won't talk about. We'll go over briefly. But number one, why do you think it's important that your sample is random? So you have to check, and you'll see the abbreviation that it, in our case, we're going to do just simple random sample, even though there's different ways of sampling. Why do you think it's so important to that your data comes from a random sample? To reduce bias. Okay, so if you're going to figure out like what proportion of your Homestead High School students think that you're cool, and you are just going to pick like your set of friends to ask, it's not really random, and the results, you're not going to be able to determine something about the larger population that you're interested in if your sample isn't random, right? Okay. So so it's important that it's random. Two, we already have the normal. We know what the normal condition is. I'll just say it verbally. For proportions, it's NP, N1 minus P greater than or equal to 10. For means, it's the central limit theorem as long as the sample size is large enough, greater than or equal to 30. So the abbreviation is going to be RNI, random, normal, and then the independent condition is also known as the 10% condition. So in order for both of our standard deviation formulas to work, we need to not sample greater than 10% of the population. Because you might say, well, let's just take a huge sample because we'll get closer to the actual answer. But no, not more than 10%. So our mnemonic R and I are always going to be what you need to check to even do your confidence interval to begin with. So then let's say we know, okay, we're good to go on those conditions. Here's the formula for your confidence intervals, and we'll get into more detail what it is for proportions and means after. So the formula is you take your statistic, and this is actually in the on the AP formula card. You take your statistic, and that is your best guess. It's called the point estimate. And when we did the activity, that was your X bar that you got on the calculator. That's your estimate. That's kind of like your best guess. Best guess. So you take that value, and then you do plus or minus. This is the formula, plus or minus. And then you're going to use what's called the critical value, and that will depend on your confidence level that you want. So if you want a 95% confidence level, what do you think your critical value will be? If I tell you it's the critical value times the standard deviation of the statistic. So 95% would be what? 2 would be your critical value. Good. So this is the standard deviation of statistic. I'm going to abbreviate. So that's the formula. And this part right here is known as if you're asked for the margin of error, it's this part. What's that number plus or minus? That's called margin of error. Margin of error. And in the future notes, I'll abbreviate ME for me, margin of error. And then the last thing is how do we interpret? In this section, we're given the confidence interval, and we have to interpret it. So the wording is really important because it's really easy to get it wrong. So there's two things: an interval and a level. So for the confidence interval, if you word it like this, you'll get full credit on the AP test, and you can do some variations in some of the words, but you kind of got to have most of this. So if you say this to interpret a confidence interval, we are blank percent confident, whatever the confidence interval, 95% confident. We are 95% confident This is recommended by, this is wording recommended by a textbook author who also works on grading the AP exams. We are 95% confident that the interval from blank to blank, whatever your margin of error is, from blank to blank, that's your interval, captures the actual value of the population parameter. Not as equal to, but captures, it's within that interval, captures the, what's the shortest way I can say this? It captures the, I'll just say population parameter. That's probably the shortest way I can say it. So that's the interval part, and then the level, to take it a step further, the level means, this is the last thing, it means that C% of all possible samples, C% of all possible samples will result in an interval that captures the unknown parameter. C% of all samples will result in an interval that captures, and that the rest is the same, that captures, I'll say parameter, I'll just say parameter because that means population. Those go together, population and parameter go together. So we're going to practice this with extra example number 1.